The next lesson is going to be Chapter 1-3, Integers and Absolute Value. Please make sure that you did not go on to Lesson 1-2, because I'm going to take that lesson toward the end of the chapter. In this lesson, we'll be dealing with integers and absolute value. One of the best ways to deal with integers when we first start looking at them or thinking about them is to use a number line. This is a number line pretty similar to the one that's on the wall in my room. Now, if you'll notice, kind of in the middle of the number line, you've got 0. Anything to the right of that are the positive integers. And you'll note that we do not put a sign or symbol in front of the positive numbers. Anything to the left of 0 is a negative integer. And those do require a negative sign in front of the integer. Usually it's about halfway up the number, but you can also do a little bit higher on the left side. The first thing is we're going to look at point A on this number line and determine which integer that is. And if we look at A, we will notice that it is at -4. It is to the left of 0. Point B is to the right of 0, indicating a positive, and it's a positive 6. Now point C is right at 0, and you will note that 0 also does not have a symbol. Now most books tell you that 0 is not a positive integer or a negative integer, it's just kind of in the middle of the number line. But we do not use a symbol there. The next thing that they're going to ask you to do with a number line is be able to put an integer on the graph and then label it. We're going to graph -7. -7 means it's to the left of 0, so we want to make sure that we go to the left of 0, make a nice dot on the -7, and this time we want to label it D. Our next integer is a 9. That's positive. We want to be to the right of 0, label with a dot and the letter E. Now notice that one of the things you have to ask yourself is, do I go to the left of 0 or do I go to the right of 0? With all negatives going to the left and all positives going to the right. The next part of our lesson is absolute value. This really just tells us how far the point is located from 0. And please note that there is no sign on the answer. It's really not a positive or a negative, it's just telling us how far away the unit is. Okay? So our first example is the absolute value of 2. Well, 2 is a positive number, but again, how far away is it from 0? It's 2 units from 0. The absolute value of -5. It's 5 units away from 0. Number 3, the absolute value of -8 is 8, because it's 8 units from 0, and 4, the absolute value of 5 is a 5 because it's 5 units away from 0. Notice that the absolute value of -5 and the absolute value of 5 are actually equal to one another. They're the same number. They are the same distance away from 0. In our next thing, we're going to apply absolute value in with algebraic expressions. Just like when we worked with expressions before, we substitute for the given variable. So in example 1, we're going to substitute the -2, and the absolute value of -2 is 2. In the next one, you'll notice that this time there's an operation inside of the absolute value. And in that respect, absolute value is going to act like a grouping symbol. We're going to have 2 times 4. we have to do what's inside those absolute values first. So this time it's going to act like a grouping symbol, or a set of parentheses. We have to do the math inside. So we're going to take the absolute value of 8, which is 8. This one's a little different than example 2. You'll notice that this time the 3 is on the outside. So we're going to substitute negative 3.5. Now, just like it acts like a grouping symbol to do the operation inside, the absolute value says we need to take the absolute value first. So we're going to have 3 times 3.5, which will give us an answer of 10.5. Part 3 is taking the opposite of a number, and this becomes very important when we get into subtraction. The symbol minus, which does in fact look like a minus sign, actually means to take the opposite of. So in A, we're going to take the opposite of 4. The opposite of 4 is negative 4. In B, we're taking the opposite of negative 4. Well, the opposite of a negative 4 is a positive 4. It's like they flip positions on the number line. In C, we've got parentheses, so we're back to order of operations. We're taking the absolute value of, or the opposite of 10. We need to do what's in those parentheses first. The absolute value of 10 is negative 10. In D, you'll notice that we have an absolute value. We do have to have that absolute value first. So we are going to take the opposite of 5, since the absolute value of 5 is 5. The opposite of 5 is negative 5. The last thing we're going to do in this lesson is comparing integers, and this is where we're going to use greater than, less than, or equal. Yeah, it's time that you learn what the greater than symbol is and the less than symbol is. You can't always just deal with alligator eating the bigger number. So it's time to really learn the greater than from the less than. The number farther to the right is the greater number. That's kind of a key concept when you're dealing with comparison of integers and even real numbers. And truthfully, even back when you were younger and you compared like a 4 with an 8, that 8 was farther to the right on a number line. So the farther to the right the number is, the greater it is. Let's look at our first example, negative 5 and 2. I'm going to draw a dot at negative 5 and another dot at 2. Now it becomes very apparent that the 2 is farther to the right. Therefore, negative 5 is less than 2. I'm going to switch a color up and use green. Negative 2 compared to negative 3. They're right next to each other, but that negative 2 is farther to the right. Therefore, it's greater than negative 3. Our third example is 0 with negative 7. Yes, the 0 is greater because it's farther to the right. Hard for us to imagine that 0 can actually be bigger than something, but it is. Technically, I suppose if you think about it in terms of money, if you have no money, you still have more money than if you owe somebody $7. So that's one way to think of it. Our next example, negative 5 compared to negative 4. So what do you think? Well, this one's got to be less than, because negative 4 is farther to the right. Oh, example 4. There's those absolute value signs. Remember, these act like grouping symbols. We have to do that first. The absolute value of negative 3 is 3. The absolute value of 3 is 3. Now we're comparing 3 with 3. They are the same distance away from 0. So they have an equal type of location. They're equidistant. And our last example is to compare 8 with 0. Yes, 8 is greater than 0. And this is the conclusion of today's lesson.